Well, we're just about to reach the Lake Hughes VOR and join the Fasto 2 arrival into Bakersfield. And I'm anticipating that once I pass these mountains, I'll need to make a somewhat aggressive descent to get down to an altitude where I can join the approach. I could potentially get 8,000 right now. That would work with the MEA in the area, but I like 10,000 for the little extra buffer over the mountains here. So let's use the VNAV functions on the GTN to start planning that descent. As long as you have a barometric altitude input to your GTN like we have here coming from the G5s, you have VNAV capability. And if you have the right Garmin HSI or PFD, you can even have a VNAV path displayed to you. And if you have the right Garmin autopilot, you can even couple to that. For this demo, though, we're going to assume that you only have the basics. You have no glide path, no autopilot VNAV modes, and we're going to work with vertical speed required and the top of descent markers on the GTN. So the MEA for the star segment that's right before Fasto here is 4,800, but my expectation is that ATC is going to get us a little bit lower than that, since the altitude on the approach chart for the initial segment that comes from Gorman here is 4,500. That's essentially the segment that we're on here. Anything above 4,500 at Fasto could actually be a problem, since it would put us above the glide slope potentially. The glide slope is at 2,500 at Jupex here, and that's a bit over 7 miles from Fasto. If you figure 300 feet per mile for a 3-degree glide slope, it'll be at about 4,600 at Fasto. It'll certainly make our life easier to not be above the glide slope at Fasto, so let's tentatively plan to be at 4,500 at Fasto, provided, of course, that that works with ATC. If we go into the flight plan here, the altitudes are already automatically imported when we load a procedure. So Fasto, it says at or about 4,500 because that is the altitude for the segment that we loaded the approach from to Fasto. So that's great, but I think I would actually like to get to 4,500 a little bit before Fasto. That'll give us some time to level off, slow down to an approach speed, and not have to make a real slam dunk approach in. The GTN makes it simple to do that. We tap on Fasto and choose a long track. This is a long track offset, and it lets you create a waypoint along your flight plan track a certain distance before or after a waypoint. And let's say I want to get there 3 miles before Fasto. That should give me time to get slowed down to an approach speed. So 3 miles before, enter, and now we have a waypoint added. Fasto -3, 3 miles before Fasto. When you look at these altitudes on here, you'll see 4,500 in cyan next to Fasto with a line below it. That's at or above 4,500, and that's a constraint in the flight plan that the VNAV is going to attempt to meet. The white altitudes, like the 5,450 at Fasto, is just telling us that based on our current VNAV profile, we'll be at that altitude at Fasto -3, 3 miles before Fasto. But I want to be at 4,500, 3 miles before Fasto, so I'll tap on that. It's set to at, and we'll choose 4,500. And save it. Now, we're not cleared down to that altitude yet, but if I go back to the map, I can already tell that if we were to start right now, I would need 580 feet per minute of descent. I also have a top of descent marker, TOD, on the map telling me when my descent should start to meet the ideal profile that we have set here. That defaults to a 3-degree descent, but you can change that. Easiest way is from the flight plan menu and VNAV. And you can see it's set to a 3-degree flight path angle. At this current ground speed, that corresponds to almost 1,000 feet per minute of descent. Let's say for my passenger comfort, I'd actually like something more like 800 feet per minute. I can change that. And that's a 2.41 degree flight path angle now. So I know that already I need to start speaking up to ATC pretty soon if we don't get a descent, because my ideal descent would start in a minute and a half from now already.
Reserve Papa is cross fast at 5,000, cleared ILS runway 30 right approach.
Cross fast at 5,000, cleared ILS 30 right, OD 750 Papa Whiskey.
All right, 5,000 feet, so that's probably as low as he can get us now, but I am going to anticipate getting lower later, and I'll ask about it if I don't. But let's start down. So I'm going to set 5,000 in my altitude pre-select. And then I'm just going to use vertical speed mode to match the vertical speed required that we have set here. So I'll roll it down to 800 feet per minute down. And this is all based on ground speed. It's based on your current ground speed. So if you expect to accelerate in a descent, you need to account for the vertical speed required also increasing as you do that. But we'll try to maintain about the same speed so we don't have to come down excessively steep.
Roger, Papa Whiskey, cross Fasto at 4,500 now, cleared ILS runway 30 to approach.
Fast at 4,500, clear ILS 30 right, OD 750 Papa Whiskey.
All right, there's a clearance to 4,500. That's what I was hoping for. And now that we're out past the mountains, you can understand why his minimum vectoring altitude is probably lower. So we'll just roll the pre-select down to 4,500. I'm going to continue to match my vertical speed to my vertical speed required. Okay, so we're leveling off here at 4,500, just before our Fasto -3 point that we picked. I can set the power to an approach setting here. And by the time we turn inbound at Fasto and the ILS comes alive, we should be in a great position to intercept it. All right, here's the turn. When the leg switches, we should get an auto switch of the CDI to VLOC mode. There it is. And I can engage approach mode. And you can see if we had been any higher here, we would be above the glide slope and we would have some trouble getting down to it. But instead, we made a good plan using the VNAV on the GTN, and it took us down to a perfect position to intercept here. So that was a basic VNAV descent, but if you don't have barometric altitude being sent to the GTN like we have here, you won't have VNAV and you'll have VCALC instead. VCALC uses GPS altitude rather than barometric altitude, and it works basically the same way that VNAV does on the GNS 530 and 430 units. So let's return back up to 10,000 feet, and we'll take a look at how you might set this up with VCALC instead of VNAV. All right, we're back up at 10,000 feet now, just about to reach Lake Hughes, and I've got the GTN configured this time with VCALC, no VNAV on it. So the way you do this now is from the home screen, you go to Utilities, and then VCALC. And this is a screen that's probably familiar if you've used VNAV on the Garmin 430 or 530, and it only works for one waypoint at a time, one altitude constraint at a time. So I can set it for a target altitude of 4,500, MSL, vertical speed profile, let's do 800 feet per minute again, and we want 3 miles before Fasto. And straight away now it's telling us that we need to begin the descent 4 minutes and 50 seconds from now, or if we started down right now, it would take a 474 foot per minute descent and counting, obviously. I can choose display messages, and then it'll give us a message when we approach the top of that profile. And if I go back to the map, I can see the vertical speed required there again, 490 feet per minute. Use vertical speed required and top of descent markers for easy descent planning and execution. Use simple mental math to sanity check VNAV guidance. GTNs with VCALC instead of VNAV can fly single constraint descents.